Hello students. In the previous video of second order derivative, I have given some homeworks to you, but in response of that, many of the students has asked me to make a separate video for the homework part because some of the students are facing some problems regarding the homework questions. So I am thinking that I will make a separate video for the homework part. So in this particular video, we are going to cover up the homework questions which are from the second order derivative. So watch the full video and try to understand the solutions of the questions that are given in the homework portion of the second order derivative. So let's start with the question number 1. So question number 1, that was the homework question. So if y equals to a e to the power mx plus b e to the power minus mx, then show that d2y by dx2 minus m square y equals to 0. So this is given to you, y is given to you, and you have to prove this part. So that means let us focus what you have to prove. You have to prove that d2y by dx2 minus m square y equals to 0. So in the left hand side, what are the things are there? The most important, that is d2y by dx2. That means you have to find the second order differentiation of y. Clear? So according to that, let us first of all find the first order differentiation of y. Okay, so you will write in this way: solution, given y equals to a e to the power mx plus b e to the power minus mx. Remember students, a, capital A and capital B are the constant part, and we know that constant always remain out of the derivative. So let us first of all find dy by dx, that is differentiating each term separately. Okay, now a is a constant. Let us take the constant out of the derivative. Now a ddx of e to the power mx, we know the formula. According to the formula, it will be e to the power mx, e to the power mx will be same, and just what is the coefficient of x here? The coefficient of x here is m, so we will write here m. Similarly for this part, what is here? E to the power minus mx, we will write similarly e to the power minus mx, and what is the coefficient of x here? Minus m, we will write here minus m. Now multiplying, opening the bracket, m a e to the power mx plus minus mb e to the power minus mx. So this is your dy by dx. Now using this, we have to find d2y by dx2. So this is a dy by dx we got. Now we will further differentiate this dy by dx. So we will write here again differentiating both sides with respect to x. Now if you further differentiate dy by dx again, that means d dx of which you are differentiating both sides with respect to x, and this side also d dx of m a e to the power mx minus this side d dx of m b e to the power minus mx. Now remember one thing, d dx of dy by dx, if you differentiate dy by dx further, it gives second order, that is d2y by dx2. Now here m is a constant, a is a constant. Let us take constant out of the derivative, that is it remain d dx of e to the power mx minus, again here m is a constant, b is a constant. Let us take both out of the derivative, and it remains e to the power minus mx. So now using the formula, e to the power mx derivative, e to the power mx same, x coefficient here is m, you will write here m, minus mb e to the power minus mx, it will remain same. X coefficient here minus m, we will add here minus m. Now opening the bracket, m into m square a e to the power mx minus minus plus m into m square b e to the power minus mx. Now in both of the term we can see that m square is common, we can take that as a common, but so after taking the common we get this expression. Now if you remember that this part, this bracket part, if you focus on the question, what was the question? Y equals to a e to the power mx plus b e to the power minus mx. Just see the question part once again. So this full expression, this bracket expression is nothing but your y. So instead of that we can write y, and this side, now taking all of the term to one side, we get finally equals to 0. And this thing we have to prove, so hence proved. Clear? Okay, now let's proceed to the next question. Okay, question number 2. If y equals to root over 3x plus 2, then show that y d2y by dx2 plus dy by dx whole square equals to 0. So now here we have to prove this expression. Now see that in the expression, what are the things we required? One, we required dy by dx. Another thing we required d2y by dx2. That means from this given expression we have to find both dy by dx as well as d2y by dx2. So let's start. What is given here? Y equals to root over 3x plus 2. For the simplicity, you can write this as root over means what is a power? Power is half. So for the simplicity of the question, let us take 3x plus 2 as u. So then your y converted in the form of u to the power half, or you can say root over u as your wish, because we have assumed 3x plus 2 as u. Now differentiating both sides with respect to x. So we get, we are differentiating this expression, expression number 1. We get here dy by dx, and this side ddx of root over u. As we know that ddx of root over x is 1 by ddx of root over x is our 1 by 2 root over x. So always we are going to use this result. So for root over u, what we can write? 1 by 2 root over u. But this is u, this is x, not same. So by chain rule, further differentiating u with respect to x. We have done this in the topic of chain rule. Now simply putting the value of u, that is 3x plus 2. This side ddx of 3x plus 2. Okay, so 3x plus 2. Okay, now directly differentiating this part of 3x. First of all, 3 is a constant, it will remain as 3. X derivative is 1 plus 2 is a constant derivative is 0. So after that what we get? Dy by dx equals to 1 by 2 root over 3x plus 2, and this side 3 into 1 plus 0, that is finally what we can write here directly 3. Or more simply we can write 3 by 2, it remains as like this, and 3x plus 2, what is the power here? (3x plus 2 to the power half). Square root means power half, and if it goes to numerator, that is if the term from denominator goes to numerator, power becomes minus. So this is your dy by dx. Okay, now using this we have to find d2y by dx2. So from here, using the dy by dx, we have to find d2y by dx2. We will write again differentiating both sides with respect to x, that is this side d dx of dy by dx and this side d dx of 3 by 2, what is there, 3x plus 2 to the power minus half. This was the expression. Now this side d dx of dy by dx means d2y by dx2. 3 by 2 is a constant part. Let us take 3 by 2 out of the derivative. Now again, for the simplicity, let us take 3x plus 2 as u. Just for the simplicity, let us take this as, okay, let us take this as u. So we got u to the power minus half. In bracket you can write, let u equals to 3x plus 2. Okay, now using the formula u to the power minus half, the derivative will be minus half u to the power minus half minus 1. Now this is u, this is x, these both are not same, so by chain rule du by dx. Minus half u to the power minus half minus 1, that is minus 3 by 2. d dx of u means 3x plus 2. Now multiplying it, plus minus, minus 3 into 1 3, 2 into 2 4, u is 3x plus 2 to the power minus 3 by 2. Now d dx of 3x plus 2 we have done is earlier, so that is 3 plus 0 we will get. So finally 3 plus 0 3, 3 into 3 9, so minus 9 by 4, 3x plus 2 to the power minus 3 by 2. This is our d2y by dx2. So we got our d2y by dx2 and earlier we got our dy by dx. This was our dy by dx. So now we will put this value and this value in the left hand side of the proof part. Okay, this is the left hand side. So first of all, y. What is the value of y according to the question? If you see that y value is given as 3x plus 2 root over. Then d2y by dx2. What is the d2y by dx2? This expression, that is minus 9 by 4 into 3x plus 2 to the power minus 3 by 2 plus dy by dx. What is the value of dy by dx? 3 by 2 into 3x plus 2 to the power minus 1, and that is whole square. Okay, this was the value. Now root over means what is the power? 3x plus 2 to the power half. Minus 9 before this will come in front, and here 3x plus 2 to the power minus 3 by 2. Okay, and this side whole square means 3 by 2. First of all, 3 by 2 whole square, that is 9 by 4, and 3x plus 2, see here, what was the expression there? 3x plus 2 to the power minus half and whole to the power square. That is the expression there. I will write directly there. What this means? Power to the power. So always remember that whenever power to the power, then the powers are going to be multiply. The powers, when power to the power means these two powers are going to be multiply. So half into 2, 2 cancel. So finally it remains 3x plus 2 to the power minus 1. Clear? I will directly use this there. So we will write 3x plus 2 to the power minus 1. Okay, now let us come to this part. Minus 9 by 4. Now here multiplication, base same, so powers are added. In multiplication, when base are same, powers are added. That is 3x plus 2 to the power half plus minus 3 by 2. Powers are added, and here plus 9 by 4, 3x plus 2 to the power minus 1. 3x plus 2. Now here half plus minus minus, half plus minus minus 3 by 2, that is taking the LCM 2, 1 minus 3, that is minus 2 by 2, cut cancel, so finally minus 1. So we can write here minus 1 plus 9 by 4, 3x plus 2 to the power minus 1. So these two are same, but this is minus, this is plus, so this will cancel out and the final answer will be 0, which is your right hand side. Hence proved. Clear? So now the question number 3. So for this expression we have to find d2y by dx2. It is very simple. First of all, what we'll do, we will take here LCM. If we will take here LCM, that is LCM is a square b square. Now just do the cross multiplication, b square x square, and here a square y square equals to 1. Now do the cross multiplication, b square x square, a square y square equals to a square b square. Remember this expression, okay? We will use this expression later on. Now we'll differentiate this expression, differentiating both sides with respect to x. Okay. Now differentiating this, that is d dx of b square x square, d dx of a square y square, d dx of a square b square. Now b square is a constant, b constant come out of the derivative, x square derivative is 2x. A square is a constant, constant come out of the derivative. Now y square derivative is 2y, but this is y, this is x, these two are not same, so by chain rule dy by dx, and this side a square and b square both are constant and constant derivative is 0. So finally, after opening the bracket, 2x b square 2y a square dy by dx equals to 0. We need our dy by dx term only, so 2y a square dy by dx equals to minus, if we take this term from this side to that side, minus 2x b square. So now what we need our this dy by dx. So for that, this 2y a square, which is in the form of multiplication, if from this side goes to that side, so it will come in division. So finally dy by dx equals to minus 2x b square by 2y a square. Now 2 cancel, so our dy by dx is minus x b square by y a square. Okay, so we got our dy by dx. Now we will further differentiate and we will get our d2y by dx2. So now d dx or dy by dx is nothing but your d2y by dx2. Okay, and this side, what are the constant part? Let us focus on that. Minus b square by a square, and here d dx of x by y. So by using division rule, we will differentiate this x by y. That is, first of all, denominator whole square, and then starting with the denominator, d dx of numerator minus, now interchanging, okay, then minus b square. Now let us take y square out of the bracket part, just writing the bracket portion. Now y d dx of x is 1 minus x dy by dx. Now dy by dx. Now dy by dx, we got the value of dy by dx, that is minus x by y, b square by x square. So we will put that value here. Minus x by b square, x b square by y a square. And now let us simplify this. That is minus b square by a square y square, y minus minus plus x into x, x square, then b square divided by y a square. Clear? Now here we take the LCM, that is minus b square by a square y square. See, what we had to take the LCM, y a square. So y a square will be the LCM. Now just do the cross multiply, y into y a square, y into y a square. So y square a square plus x square b square equals to 0. Now did you remember the expression number 1 of this question? The expression was x square b square plus y square a square equals to, using expression number 1, a square b square. You will write here using 1. So now let's see what are the cancelling term. So here we can see that a square cancels, and a square cancel, and b square into b square, that is b to the power 4, a square only a square, and y square into y cube. So this is your finally d2y by dx2. Clear? Now this was the bonus question, and now we have to solve this question. And now what is the question here? If y equals to x plus square root of 1 plus x square to the power m, then prove that 1 plus x square y2. First of all, y2 means, we all know that y2 means second order derivative d2y by dx2 plus x y1. y1 means dy by dx. Okay, remember this thing. Differentiation of y1 is, if I say d dx of y1, always remember that is y2. That is simply, we have done this multiple times. d dx of y1 is nothing but your dy by dx is, we know that d2y by dx2, and d2y by dx2 means y2. So just writing in the short form. So now back to the question. So here first of all what we'll do, we will assume the bracket part, that is x plus root over 1 plus x square as u. So we will assume this as u. So then your question will convert into a short form. Now this bracket part is your u and the power is m, u to the power m. So now we'll simply differentiate, that is we'll find our dy by dx, that is d dx of u to the power m. Now u to the power m is m, simply differentiation of x to the power n. Just think like we are differentiating x to the power n. The differentiation is n x to the power n minus 1. Just using that formula, m u to the power m minus 1. Now this is u, this is x, these are not same, so we will write du by dx. So after that, putting the value of u, that is m u to the power m minus 1. Now just putting the value of u, d dx of x plus root over 1 plus x square. Now if you have watched the previous video of second order derivative, and the question number 9 was similar to this one. In question number 9 also, we have just differentiate this part, x plus root over 1 plus x square. So here I will just directly write the answer. d dx of x, first of all, d dx of x, I will not write here, d dx of x is 1. We know that d dx of x is 1. And here d dx of root over 1 plus x square. Okay. Now similarly we will assume 1 plus x square as some new variable v. Let 1 plus x square equals to v. So the new form will be m u to the power m minus 1, then 1 plus d dx of root over v. Just assuming this 1 plus x square as v, then m u to the power m minus 1. Root over v derivative is, we know that root over x derivative, so we'll directly write 1 by 2 root over v, and then this is v, this is x, these two are not same, so we'll write dv by dx. Now putting the value of v, m u to the power m minus 1, 1 plus d dx of, okay, wait. So after the putting the value of v, that is 1 plus x square, we got this. So now let us simply differentiate. I am not putting the value of u, at the end we will put the value of u. This derivative differentiation of 1 is 0, differentiation of x square is 2x. 2x plus 0, 2x, and 2x into 1. So finally this is our 2x. 2 cancel. So after cancelling 2 what remains here? Only this part. Now here we are going to take the LCM. If you take the LCM, cross multiply 1 plus x square plus x, close the bracket. Now x plus root over 1 plus x square is nothing but your u. What was the u? X plus root over 1 plus x square. So x plus root over 1 plus x square. So instead of that we can write u by root over 1 plus x square, and this side it was dy by dx. Clear? Now this is in the form of multiplication. U to the power m minus 1, u to the power, what is the power here? 1. And in case of multiplication, powers are added. We know that. That is m minus 1 plus 1. So after that, dy by dx equals to m u to the power m minus 1 plus 1 divided by 1 plus x square. Minus 1 plus 1 will cancel out. Finally what remain? M u to the power m by 1 plus x square dy by dx. And if you remember, u to the power m, this expression was nothing but your y in the starting of the expression question. So instead of that we can replace finally dy by dx equals to m y by root over 1 plus x square. Okay, now just do the cross multiplication. Now just do here cross multiplication. Now cross multiplying them, we get root over 1 plus x square dy by dx equals to my. Here just doing the cross multiplication, which is sending this to that side. Now squaring both sides, squaring both sides. So if we square both sides, we will get 1 plus x square, because square of this, that means square root will removed, and this will become dy by dx whole square, and it is m square y square. And dy by dx, that is nothing but your y1 square. Dy by dx means your y1, and that is whole square, that means y1 square. Clear? Now differentiating both sides with respect to x. ddx of 1 plus x square y1 square ddx of m square y square. So after that, here 1 plus x square y1 square, that means product rule. Product rule means at a time only one differentiate and another will remain out of the derivative. Y1 square, and here y1 square ddx of 1 plus x square, and in the right hand side, what is a constant? M square is a constant, so let us take m square out of the derivative, and ddx of y square. Very careful about that. Okay, now y1 square, very much careful. Y1 square, see what was there, ddx of y1 square, right? This was the term there. Now we know that ddx of x square is 2x, so y1 square will be 2y1. Similarly, first of all, now this is y1, this is x, they are not same, so by chain rule further differentiate. And what was the y1 we have? Y1 means dy by dx, this is our y1, and further differentiating y1, that means this is nothing but your y2. dy by dx is nothing but your y2. At the starting of the question I have said that dy by dx is nothing but your y2. So finally ddx of y1 square we can write 2y1 y2. So here we can write 2y1 y2. This side y1 square, ddx of 1 plus x square, ddx of 1 is 0, ddx of x square is 2x, so finally 2x. This side m square y square derivative 2y. Now see here, what was there, ddx of y square, right? This was a term. ddx of x square 2x, ddx of y square 2y, this is y, this is x, these two are not same, so dy by dx, and dy by dx we know that dy by dx means y1, so we will write 2y y1, so we write 2y y1. Clear? Now let us focus what are the common terms they have. So if we can see that if in both of these two terms 2 factor is common, so let us take 2 as a common, and one more common thing is there, we can see that y1 and y1 square, so y1 term is common, so we will take y1 common. So the first term what we get, 1 plus x square, which is in the bracket, 2y1 we have taken common, so only y2 remains, plus from here 2 we have taken common, so from the bracket only x remains, and y1 we have taken common from y1 square, so only y1 remains. Clear? Now for this side 2y1 we kept it separately into what are the other terms, m square and y. 2y1 from the both side we can cancel. So finally in the last line what remains, 1 plus x square y2 plus x y1 equals to in the bracket m square y. This was your required proved, so we have proved the bonus question. So this about all about the bonus question. So I have tried to solve some of your homeworks question of second order derivative. After that also, if you find any doubt, any queries regarding any step, any calculation part, just let me know. I will try to again resolve your queries. Okay, so try to understand the solutions of the homework part and try to solve some more questions based on the second order derivative. This is an important topic for your exam purpose. Okay, so thank you for watching this video. Goodbye.